Yesterday, we talked about 3 different types of quantitative variable displays, so histograms, dot plots, stem plots. As far as those displays go, like I said, the histogram is probably the most common. As far as what we see or what we will use later on, histograms are kind of going to be the thing. So that's the one you really want to focus on. Dot plots and stem plots, those are better for kind of smaller data sets, but they can still be useful in some cases. So you'll see them being utilized, just not always as often as the histogram will be. So the things from yesterday to make sure you remember, histograms are not bar graphs. Okay, we treat the histograms and bar graphs somewhat similar in that we have groups that we've broken our data into and create bars for them. But in the bar graph, those are completely separate groups. So group 1 has nothing to do with group 2, has nothing to do with group 3, and so on. With a histogram, those groups all run into the next. So it's just a continuous range of values that we're accounting for in those histograms. Okay? So creating graphical displays is one thing, but most of the time we also need to know how to analyze those graphical displays. We need to know how to describe them. We need to know how to read them, to pick out the important things that we would need if we're trying to make an informed decision based on either someone else's research or things you would be able to need to convey if you were doing your own research and trying to tell other people about it. All right? So, as far as examining a distribution goes, what you're really trying to do is take the distribution as a whole and look at the overall pattern. So what's happening overall with this particular distribution? We don't really focus on little parts of it here and there. It's just overall what's happening in the picture. Things you want to take note of. Once you kind of have established a pattern, if you can see a trend occurring somewhere within the distribution itself, you want to look for any deviations, anything that doesn't follow the norm. So anything that looks a little off, so maybe a point that's way larger than the rest or way smaller, maybe some like a gap, things like that. So those are things you kind of want to look for. Specifically, outliers, and we'll formally define outliers a little bit later, but for the most part it's just individual values that lie outside the pattern. Okay, so outliers are values that don't follow what the rest of or the majority of the distribution looks like. So you might have a bunch of values around the 40s, 50s, and 60s, and then all of a sudden you have a value up in the 90s or 100s. Okay, so something that's way outside the norm. Those are things we definitely want to look for. So we look for the overall, what's happening for the majority of our data, but we also want to take note of any values that don't follow that trend. So anything that falls way outside, either above or below or whatever else might be going on. When you describe histograms specifically, because like I said, that's what we're going to be looking at most often. But this works for dot plots, it also works for stem plots. So if you are looking at a graphical display for a quantitative variable, you need to make sure you comment on 3 different aspects. You always need to comment on its shape, and we'll go more in depth in that here in a second. You need to comment on its center. Which center value you choose will depend entirely on the shape that you used in the first part. So there's going to be 2 different measures of center that we'll deal with. One goes for a specific set of distributions, the other goes for a different set. So once you've identified what shape you're working with, that's going to determine which center value you choose. Once you've chosen a center, you can then choose your measure of spread. That's going to be the last thing you need to comment on. So anytime I ask you to describe a distribution, so here's a picture of a histogram, or here's a picture of a dot plot, describe the distribution. I need to see an explanation of all 3 pieces. What's the shape? What's the center? What's the spread? Okay, and we're going to kind of ease into this a little bit and talk about just little aspects here today and then kind of build on that over the course of the next couple days. But these 3 things always have to happen: shape, center, spread. Okay? Like we said, we're looking at the overall pattern. So things to look for are peaks, major peaks. So when we're looking at a distribution, you might have a histogram looks something like this. Okay? When we talk about the overall pattern, we're saying look at the whole thing in general. And when we talk major peaks, we're not talking about the fact that this class was up higher than this class, so it dropped back down. This is not considered a peak. Okay? The fact that the next class dropped down a little bit in count doesn't make that a peak. Or over on the other side here, so we started down here, we dropped down, and then we popped back up. This is not a peak. Okay, those are not individual peaks, so they're just little minor differences. That's just part of the randomness that comes from gathering data. So when we talk about peaks, we're talking about the overall major peak that might occur.
Does it apply even for like ranges, like huge?
Mm-hmm. Yep. Okay. Now, let's say we have a set of data that when we graph, or we make a histogram for, let's say it starts off like this, and then all of a sudden we get something like this as well. There are times where our data might come out this way. All right, so we might have more than one peak, but notice when we talk peaks, we're talking about the major peaks, not just individual little jumps here and there. So it's always looking at the overall. So in this case, if we have two different peaks, we would want to take note of. And we'd want to know why. Why do we have two separate peaks here? Is there some way that I collected the data that I might want to change? Things of that nature. Okay? So that's the first one there. And we'll talk about that here in a second. But ignore small ups and downs. Those little changes throughout aren't really a big thing. Okay? We want the major peak, no matter how far or how long the range of values are. So, before we get into the specifics of shape center spread, let's talk a little bit about outliers. In some cases, outliers can be more interesting than the actual data itself. So they might have something interesting to tell us about whatever we happen to be looking at. So when we look at outliers, we're looking at values that fall outside the norm. So when we look at this histogram here, most of our data falls within this 8 to 16% range. Okay? So 8 to 16% has most of the data, but we have some gaps, and then we have an outlier way at the top here. We have an outlier way at the bottom here. Now what this histogram is displaying, it's tough to read the axis there, but they're looked at the percent of state residents age 65 and over. So they went through all 50 states, and they looked at what percent of their population is age 65 or over. So most of the states have a percentage from 8 to 16%. That's how much of their population is made up of people 65 and older. But we had one state way up in the 18 to 19% range, and one state way down in the 5 to 6% range. When we see these outliers, the first thing we should do is start to examine them. Why do we have these outliers? What outliers are they? Because in some cases, an outlier may be as simple as you just recorded a value wrong. And once you fix it, it's gone and it fits right into the rest of the pattern like it should. Other times, there's something actually happening. Something that is causing those points to be higher or lower than what the rest of the trend looks to be. So, if you had to guess, one state way down the bottom, one state way up at the top. Those of you who haven't printed off the notes yet, what states do you suppose those would be?
I think the state with a lot of would be Florida.
Okay, Florida. What about the one with the lowest? Okay, possibly California. Any other guesses? What state do you think would have a really low number of 65 and older? Okay, possibly New York. Alaska. Okay. So the first thing you would do is start examining, right? Now what they did was they saw these two outliers and they looked them up. And they are Alaska and Florida. Okay, so Alaska is the one with a very low percentage of people age 65 and over. Florida, very high. Now, when we see what happens here, so when we actually see, okay, Alaska and Florida, well, what's explaining this? Why would these two states possibly fall so far outside the rest of the states? Why does Alaska, for instance, have such a low percentage of people age 65 and over?
That's placed on the edge.
Okay. it's a tough place to live, right? In some parts of Alaska, it's light for 6 months at a time and dark for 6 months at a time. The weather can be very extreme. So as the people get older, that's not the place they really want to be at, right? Why would Florida be so far above the rest? Okay? They like the warmth, but that's not always the only reason. It's because the humidity is a little bit better. A lot of things, it's health related. A lot of times, if you go there, when you get older and you start having problems like either with respiration, things like that, they tell you want to get to a more moderate climate. And so Florida, with its warmth, with its humidity and things like that, it actually helps people with certain health problems that they may develop with older age. Okay? And plus, it's just a nice little retirement spot, right? Lots of people retire down to like Florida, Arizona, those areas. Okay? But that's the kind of thing you would need to look at. When I see my overall trend, I see some outliers in there. Well, what are those outliers? Did I make a mistake when I collected my data, or is there a reason? What's the reason that these fall so far outside? So those are important things to make sure you look at when you are analyzing a distribution. Okay? So now, let's talk about the actual descriptions. What are things you need to be able to say? And like I said, we're going to talk about the basics today. We'll get more into it tomorrow and Thursday and so on. But when we describe our distributions, today we're going to kind of talk about the basics. When we talk shape, basically shape has two different aspects. It's either going to be symmetric or what we call skewed. And that's going to depend on where the peaks occur and how the tails of our distribution appear to be. So we have symmetric, we have skewed. Those are kind of the two main words or terms you need to use when describing shape. So symmetric. When you say something is symmetric, what does that mean? Okay, like mirror images, right? The left and right side are identical, or the top and bottom are identical. So symmetry, you guys have seen before, when we say it's symmetric, we're saying that there's a mirror image. So when we say a distribution is symmetric, we're saying that where the peak occurs, so in this case, the peak here, kind of right in the middle, the left side and the right side appear to be pretty similar. If we were to fold this graph over the middle, the left and right hand side should match up fairly well. Okay, so a symmetric graph, the right and left sides of the data are approximate mirror images of each other. Okay. Now, when that peak starts getting shifted one direction or another, so right now the peak's right in the middle, and then the left and right hand sides are pretty similar in terms of counts and things like that, in terms of looks. But if that peak gets moved, either earlier in the data or later in the data, that's where we start getting the skewed nature. So skew comes in two directions. When we say a distribution is skewed right, it means that the right side of the histogram extends out more than the left. So the right side is longer than the left. So when you see skewed right distributions, you're hitting a peak fairly early on in your range of values, and then it starts to taper off as you increase that value of x. So any type of distribution where you would expect a lot of values to be on the lower part of x and fewer values to be on the upper part of x would have skewed right distributions. Think of in the housing market. If you looked at the cost of houses, the price of houses in, let's just say, the Papillion area, we would expect that to be a skewed right distribution. There would be quite a few houses in the lower kind of range of prices, from like the $100,000 to $200,000 to $300,000 houses. But there are some that go quite a bit higher. There are some that get into the $500,000, $600,000, $700,000, $800,000, maybe $1 million. I don't really know, but we expect those houses, some to be a little bit higher. But for the majority, they're going to be concentrated down in the lower prices. Okay, so things like that are going to be skewed right. We hit a lot early on in the x values, and then as they get bigger, we start seeing less and less. So skewed right, tail falls off to the right. A way to think about that, because people always get skewed right and left mixed up. If you imagine this as a ski slope, you got a skier on the top here. Okay, for safety, which direction would he want to ski down? Would he want to ski down the left, or would he want to ski down the right? Down the right. We're thinking safety right now. This is a much more gradual slope. This side is almost a complete drop-off. Okay, so he wants to ski right, so skewed right is the direction for our graph. Skewed left, then, is the exact opposite. So the left tail of our distribution extends farther than the right side does. So it's a gradual slope down to the left, kind of a steep drop-off to the right. So this is one where the lower x values are very rare, and as we increase the value of x, we start seeing more and more values appear. So as far as describing shape, these are kind of the main things to take note of. Is it symmetric, or does it have a skew to the right or skew to the left that we're noticing? Now, as far as the skewed versus symmetric goes, unless you see a very obvious skew, like an obvious tail, so the left side is obviously longer than the right, or vice versa, most of the time we'll say a distribution is fairly symmetric. So the only time you're going to start using the skew is if you really start to see one tail fall off farther than the other. Okay, so when you're describing, most often you're going to see something that's symmetric or fairly symmetric, slightly skewed right, slightly skewed left. You can use auxiliary words. So if you don't want to say it's definitely symmetric, you can say it's fairly symmetric. And that tells us that while it's not perfect, it's pretty close. Or you can say it's slightly skewed. So it's not quite symmetric, but I'm not comfortable saying it's completely skewed, so we'll say it's slightly skewed right or slightly skewed left. So you can use words that kind of lessen the effect of those descriptions. So, if we go back to our original histogram here, as far as shape is concerned, how would we probably describe this one? What do you guys think? Okay, so she says it's pretty symmetric. You guys agree? Yeah, for the most part, it's pretty symmetric. If we look at kind of the middle, right around here, the 12 to 13% range, the left and right side, now, are they going to match up exactly? If I fold it over, no. But that's okay. When we talk about symmetric, we're not saying they have to be exact mirror images. We're just saying they're going to be close to each other. So if we look, some people might try to say slightly skewed left. It might look like this left side kind of tapers off a little more than the right side. But for the most part, if I were to fold these over, the pieces match up fairly well. Okay? So I would say for this one, it's fairly symmetric. Now, another term I'm going to throw in here is this idea of unimodal. When you look at a set of data, if I were to say find the mode of the data, what does that mean? The one you see most often, right? So unimodal means it's got one peak. There's one value that really shows up a lot more than any other. So like right here, the 12 to 13% range would be our mode. We see the most values right in that range. So when I say unimodal, it means there's just one peak to our graph, to our distribution. If there are two peaks, so if we had a distribution that, kind of like what we had on that first slide, okay, so something like this, we can see two separate peaks. There's a set of data here that has a peak with it, and then another set that almost seems to appear over here with its own kind of peak. That would mean there's two different modes. So we would call that bimodal. So if you see two major peaks appear within your distribution, you would call that a bimodal distribution. Anything more than two peaks, so if you get data that has like 3 peaks or 4 peaks or more, you would just call that multimodal. So you got unimodal, 1 peak overall, bimodal, 2 peaks, or multimodal, multiple modes throughout, multiple peaks. We okay with shape? All right. Center. So once we've established shape, we can now talk about center. Now for today, we're only going to talk about one measure of center. Tomorrow, we'll talk about the second and when we use each one. So for the center of the distribution, as far as describing where it's at, with a symmetric distribution, the center is very easy. It's right in the middle. So if our distribution is symmetric to start with, we just pick the middle value, that's going to be our center. But if we have a distribution that is skewed, or if we have a distribution with more than one mode, so if we have a bimodal graph, that center value can be a little bit tougher to identify. Now, when we describe center, there's going to be kind of two different scenarios you're going to be working with. One, they're going to give you a data set. They're going to have you create a graphical display, so a histogram or a dot plot or whatever. And then it'll say, describe the shape, describe the center, describe the spread. Well, as far as center goes, if you actually have the data values in front of you, you can calculate the exact center. And you have to calculate the exact center. So on a test or a quiz, if I give you a set of data and I say, graph it and give the shape center spread, you need to use the values to calculate the actual center. All right, so if you have the values at hand, you have to calculate the center correctly. But the other situation that might arise is you might be given a graph, so they might give you a histogram and say, give the center. Well, if you don't have any accompanying data, the center can be fairly tough to pick out. And so at that point, you just have to kind of give your best guess. Where does the center appear to be in my graph? And in those situations, I'll have like an acceptable range of values. The center should be here, but if you miss it within a certain amount above or below, you're still going to be okay. So in some cases, you do. You just have to guess based on the graph alone. But if you have the actual data, you can go ahead and calculate the actual center and have the correct value with that. So when we talk about center, like I said, there's two different kinds. We're going to talk about the median today. When you guys talked about central tendencies way back, I think this was like even elementary school, you talked about mean, median, and mode, right? So mean was the average. Add up all the values, divide by the total number of observations, you get your average. Median was the exact middle of the data, and then mode was the one that most often shows up. Now, we don't calculate mode in ours. We care about median and mean. We'll talk about mean tomorrow. Today, we're going to talk about median. And as you guys just described, median is the midpoint of the distribution. So if I lined up all of my values from smallest to largest, and I found the exact middle value, that's going to be my median. So another way to describe that is the value that has 50% of the observations above it and 50% below it. So 50% of your data points should be less than the median, 50% should be greater than the median. So when you look at a graph, and again, when you have a graph with no accompanying data, the best you can do is just guess as to where the center of the data is going to be. So where's the center of the graph? So in this case, they picked right about at 7. So a magnitude of 7 seemed to be the good cutoff, so that 50% of the observations are less than 7, 50% of the observations are greater than 7. If this were a test or quiz, I would probably be okay with you have chosen 6.8 or 7.2, somewhere within that range of values there. Okay? So as far as guessing, when you're picking the median out, you're just kind of trying to pick where's that exact center so that 50% is above, 50% is below. The other thing, when you report your median, you must have units. So if your data points have units on them, you need to make sure your median has units. So if I was measuring in centimeters, my median is 10 centimeters. Or if I was measuring in pounds, median is whatever pounds. So always report units of measure with any of your measures that you report. So center, spread, when we get to that here in a second, always report units with anything you report of your data. Okay? Calculating mean. I wouldn't write all this stuff down. I'm pretty sure you guys know how to do this. Plus, tomorrow or Thursday, we're actually going to talk about how your calculator will do all this for you. So this is just the process of what you'd actually be doing. You do have a couple problems in the homework where you have to do this by hand, but it's like with data sets of 5 or 6 or something like that. So nothing too extenuous. So first thing, arrange observations in order from smallest to largest or largest to smallest. It really doesn't matter. Just put it in ascending or descending order, and then find the middle value. Okay? Now there's two situations you can run into. If your data set has an odd number of observations, then you can actually find the exact middle point. There's going to be a point that separates it exactly 50-50, so that's your median. If you have an even number of observations, when you get to the middle, you're actually going to find that the middle is between two values. So there's two values that actually split the data in half. So if you get to that part, you need to actually average those two middle values. So add those two together, divide by 2, get the actual median. So in that case, the median is not necessarily going to be a value from your data set. So a couple quick examples. If this is what we were looking at, put them in order, smallest to largest, pick out that middle value. Okay? And you can do that by using your fingers and just working your way in until they meet in the middle. It's the easiest way. Like I said, you're not going to do a lot of this because your calculator will do it all for you, and we'll get to that, I think, on Thursday. Second example, if you have an even number of observations, here's where when you follow it to the middle, we actually find that it's in between two values. So we take the values on either side and average them. So take the 39 plus the 42 divided by 2. So the median in this data set would be 40.5. Okay with that? All right. So that's median. That's the center. So that's the only type of center we're going to talk about today. So on the homework, when you're describing shape, center, spread, your center, you're just going to choose median for today. We'll talk about mean and how it applies to distributions tomorrow. Now spread. This is one that you may not, or you may have less experience with. The spread gives a description of how the data varies around the center. So knowing the center value is important. We do want to know where the exact middle of our distribution is or what the average is. But what might be as important, if not more so, is how does the data vary around that? So we know where the middle is, but what does the data look like around that point? Okay? Whenever you describe a distribution numerically, you always report a measure of spread with its center. You cannot report a measure of center without also having a corresponding measure of spread. So shape, center, spread. Center and spread always have to go together. Okay? And we'll talk about when we choose median, we choose a very specific measure of spread. When we choose mean as our center, we will choose a very specific measure of spread. They have to go together every time. Okay? So, one measure of center, or one measure of spread is called the range. The range is the difference between the maximum value in your set and the minimum value. Now, just like with center, there's two different scenarios you're going to run into. Sometimes you will have the actual data, in which case you can find the maximum and the minimum, subtract them, and find the range. Other times you might only be given a graph. So if we look at our original histogram from that first slide, we don't know what the values are here. We just have an idea of about where they fall. So when we calculate range here, we're just going to have to kind of estimate. So when we calculate range, one thing to keep in mind about range, I guess before we get to calculating it, range has a very big disadvantage. When we calculate it, it is very easily influenced by either very large or very small values. If most of our data falls within a given set of values, and then all of a sudden we have a really high outlier or a low outlier, or both in our case here, our range becomes much larger than what we would typically want it to be or what we would expect it to be because of that outlier. So they're very easily influenced by extreme values. So when we calculate, like we said, we take the maximum value minus the minimum. Now, I went ahead and calculated based on the exact values. So from the table, I found that the maximum value was 18.7%. So Florida had 18.7% of its residents age 65 or older. Alaska had 5.2% of its population at 65 or older. So when I subtract these two values, I get my range. Range is one number. It is not range like you guys think of it from algebra. It's not a range of values. It is one specific number. It's the difference between the maximum and the minimum. So when I say report the range, I want the one number. What is the maximum minus the minimum? Okay? Now, when I calculated range here, like I said, I went ahead and accessed the information so I could find the exact range. If we didn't have access to that, so all we had was the picture here, what would I use for my maximum value? So up here, this is the 18 to 19% range. We'd have to use 19. So we don't know what percent of residents are age 65 and over in Florida, but we do know at most it's going to be 19, right? And then for Alaska, we don't know what it is between 5 and 6, but we know it's at least 5. So we would take 19 minus 5. That would give us our range, or at least as close as we could get without knowing the actual values. Okay? So if you have the actual information, calculate the range exactly. If all you have is the graph with nothing else to go on, estimate it. Take the max in the graph minus the min in the graph and call it good. That's as close as we can get. Range has the exact same units as the rest of the data as well. So make sure when you report range, you give it in units. Whatever was in the problem, that's what you use for that. Okay? Last thing here, comparing distributions. So the whole reason for us to be able to talk about shape, center, spread is so that when we have more than one distribution, because in a lot of cases we compare values, we want to compare groups. How does this group compare to this group and so on? So if we have graphs, we can use our shape, center, and spread to compare which one seems to have a higher center, or which one seems to be more variable. What do the shapes look like? So is one distribution different than the other distribution? Things like that. So some of the most interesting questions in stats involve comparing two or more groups. So when they ask you to compare two different groups, you need to comment. How do the shapes compare? Are they both symmetric? Is one symmetric, one skewed? Are they both skewed? Where's their center? Center for group 1, center for group 2. How do they compare? Is one bigger than the other, or are they pretty much similar? And then spread. Now for spread, the only thing we know about right now is range. So you just calculate the ranges and compare them. Okay? So, just as a quick example here, this will kind of give us an idea of how to comment on shape center spread and how to compare all at once here. So, we have household sizes. So they went through, we have South Africa on the top and the UK on the bottom, and they measured the household sizes for a specific sample of people. So here are the household sizes, so ranging from 0 to 30, 0 to 30. Make sure the scales stay pretty similar. Okay? So if we wanted to compare these distributions, for South Africa, what would we say about the shape? Okay, so it looks to be skewed. It's definitely not symmetric, right? This right side definitely tapers off more than the left side does, because here's our peak almost immediately right off the bat. So it's going to be skewed right. How many modes? How many peaks? Just the one, so we could even say it's unimodal. Okay. Now let's compare that to the UK. What do we see about the shape of our distribution for household size in the UK? Yeah, in this case, it's pretty symmetric. Now, there are some higher values on the right side than on the left, but there's not a tail that tapers off more or less than the other, right? So we would say for this one, it's pretty symmetric. So right there, we've got a difference between the two. This one's very skewed right. This one's pretty symmetric overall. If we look at the center, so what would a typical household size in South Africa appear to be? So if we tried to cut it basically in half right now. Yeah, probably somewhere in the 6 range, right? If I cut off right about here, that seems to be about close to a 50-50 split. So center, we'd say somewhere around 6. Okay, range, so if I talk about spread, let's just do that while we're here. So if I wanted to calculate my range here, my highest value appears to be about 26 or so. My lowest value appears to be 3. So we would take 26 minus 3 for a range of 23. Okay. Same thing for the UK. If we look at the center appears to be at probably right here at 4. So about 4 people per household with a range of what? 3. Or actually probably 6 minus, probably goes 2, so 6 minus 2. So with a range of 4 people per household. Okay, so if we're comparing just based on this information, one major difference. In South Africa, the shape is skewed right, whereas in the UK it's symmetric. There appear to be roughly 6 people per household on average. That's what the center kind of tells us, compared to 4 people per household on average in the UK. And the spread, the distribution is much more variable for South Africa than it is for the UK. The UK is pretty tightly clustered around a single value. So the range of 23 people per household versus 4 people per household is quite a significant difference. So those are the kinds of things that you would be asked to do. It's just comment. How do the shape center spreads differ, or how are they the same or similar between 2 groups of individuals? Okay with that? Okay. Here's your assignment. The answer key for this will be posted probably sometime during lunch. So you can kind of have access to that as you work tonight. One of the things you'll notice when you check the answer key, there will be extra problems on the answer key that you don't have to do. So I did eliminate some of the problems from last year. So only pay attention to the problems that actually pertain to this assignment. So they should all be there otherwise.